Have you ever pondered over how electricity is generated? What magic brings life to your favorite gadgets, powers your homes and fuels the digital world we live in? It is a scientific marvel that we often take for granted, yet it is central to our modern existence. Today we delve into the fascinating world of electromagnetic induction, the unsung hero of our electrical world. First things first, what is electromagnetic induction? In simple terms, it is the production of an electric current across a conductor moving through a magnetic field. Now, that might sound complex, but stick around, and it'll all make sense soon. Picture a peaceful lake. When a stone is thrown into it, the calm surface is disrupted, and ripples form, spreading outwards from the point of impact. This is very similar to what happens in electromagnetic induction. Think of the magnetic field as the calm lake, and the conductor, such as a wire, as the stone. When the conductor moves, it disrupts the magnetic field, causing ripples of electricity to flow. Now, it's important to understand that the strength and direction of the electric current produced depend on a few factors. These include the speed at which the conductor moves, the strength of the magnetic field, and the angle at which the conductor cuts through the magnetic field. This phenomenon was first discovered by a brilliant scientist named Michael Faraday in the early 19th century. Faraday's law of electromagnetic induction, as we know it today, states that the induced voltage in a circuit is proportional to the rate of change in the magnetic field through the circuit. There are two key terms in Faraday's law that require a bit of elaboration: induced voltage and rate of change. Induced voltage simply refers to the electric potential that is created due to the changing magnetic field. Rate of change, on the other hand, is all about how quickly the magnetic field is changing. The faster the change, the greater the induced voltage, and thus the stronger the electric current. But how does all this translate into real-world applications? It's simple. Every time you flick on a light switch, charge your phone or use an electric kettle, you're benefiting from electromagnetic induction. Power stations use this principle to generate electricity, which is then transmitted to our homes, schools and workplaces. It's the heartbeat of our modern electrical infrastructure. In summary, electromagnetic induction is a process where an electric current is generated when a conductor moves through a magnetic field. The strength and direction of this current depend on the speed of movement, the strength of the magnetic field, and the angle of movement. Discovered by Michael Faraday, this principle is the cornerstone of electricity generation and forms the basis of our modern electrical world. So the next time you switch on a light or charge your phone, spare a thought for the marvelous science of electromagnetic induction and the man who discovered it, Michael Faraday. It's thanks to them that we can enjoy the comforts and conveniences of our modern, electrified world.